One thing to say about partial eclipse, or any time you're looking at the sun, don't look at the sun without certified solar eclipse eye protection. So check for the ISO standard 12312-2 and read the instructions. Check that they're not scratched or damaged from any previous use or in shipping, for example. And when you're looking directly at the sun, none of these things are really going to protect your eyesight. You need to be particularly careful also when looking through an SLR camera or DSLR, where you have a direct optical path through the lens. You do not want to look at that without a solar filter on the front of the lens. That's particularly important. If you have a more modern mirrorless camera, for example, then you have an electronic viewfinder, and there's no way for the electronic viewfinder to have an image that is bright enough to damage your eyesight. But it can damage your camera. And I think that's one of the interesting questions about this upcoming eclipse. Do I need a solar filter? Basically, the answer is yes, you do. If you don't have one, you're running the risk of damaging your camera's sensor due to the thermal heat and the energy that's being concentrated onto it. And as I mentioned, if you have an SLR and you look through it, then you probably will permanently damage your eyesight. So please take note of that. Here are some types of solar filters that I've used and tested before. There are lots of them out there, and these are all reputable manufacturers that you could buy from. Star Guy is one maker who uses this Bada Astrofilm. It's I think a metallic coated film that gets mounted into a filter holder, and it gives a slightly blue cast to the images. This Nisi, I guess, I don't know, solar filter, 16.6 stops, it says. It's not just a regular ND filter, it is a solar filter, so it does more in terms of the range of wavelengths that it blocks. And it gives a nice clean white image here. The Thousand Oaks optical black polymer solar filter sheet, which is very cost effective, gives this artificial orange hue to the images, which you can adjust. You can adjust all of these in post if you wish. None of these are capturing exactly how the sun looks. This is probably the closest. The sun's light is basically white, except at the extremes of the day where it's getting scattered, and then it sort of looks like this, but this isn't the real color of the sun. This is the filtered color that's reaching your camera sensor. So any of those will do the trick for you, and there are many others out there too. Check the reviews and see what you like. But do you need a solar filter? With all of the above, there is a question of whether, if you're photographing this event at sunrise, or if you were somewhere in Russia, I suppose, at sunset, do you need a solar filter? So let's look at some of the considerations there. So this chart, it shows solar irradiance here on the y-axis, measured in watts per square meter. So it's essentially a power density, if you will. And the solar altitude in degrees. So 0 is essentially sunrise or sunset. 90 is if you were in the tropics and the sun's literally directly overhead, 90 degrees. And you can see that at the start of the day, the power, the irradiance is really very low. And then it climbs very quickly up and levels off and reaches its maximum of just over 1200 here. This is a theoretical model. And it's assuming sort of clear skies as well. And it's assuming that the air is clean, or averagely clean, if you will. Pollution, clouds, water vapor all reduce the amount of irradiance that the sun, from the sun, that will reach you, the observer. So the thing to conclude is that at low altitudes you have low power. So that's one thing to think about. There are sort of two concepts of of irradiance. There's the direct sunlight, the direct irradiance, and then there's diffuse irradiance, which is scattered light. Now the Earth's atmosphere itself will scatter light even on a perfectly clear, dry day, and it's typically modeled at about 10% of the total irradiance is the diffuse, and the rest is direct. And really, for the purposes of thinking about your camera, it's the direct irradiance, the irradiance that really matters. That's what's going to be concentrated sunlight hitting the sensor of or the film of your camera. And this is just a view in Belfast, Maine. So that's one of these eclipse locations on March 29th. Again, clear sky irradiance. We're not assuming any clouds, any pollution beyond sort of average conditions. And you can see this is from the moment of sunrise. This is UTC, so it's actually sort of 6:20-ish Eastern Daylight Time. And this is how the irradiance climbs over the first hour after sunrise. So by the time you get to sort of 0.45, 0.5, we're nearly at half of the sun's maximum theoretical power. But for the first, say, 15 minutes, we're down at 0.1. So if you're thinking potentially you're not shooting video, which, for example, which will leave your sensor exposed continuously, and you're not taking, constant exposures, all of that constant exposure will allow heat to build in the sensor and in the camera, both from its normal functioning and also by virtue of the sensor remaining exposed to the sun. If you're taking stills during these early minutes after sunrise, you may be able to get away without a solar filter. You might consider an ND grad filter just to manage things a little bit. You can get variable ND grads. I have one from Stingray that allows you to essentially counter-rotate two polarizing filters to reduce the amount of sun. You can get some artifacting and those things, so you need to make a choice there as to how to approach it. The other thing that affects irradiance, and therefore what's going to hit your camera, is clouds. So you can adjust these theoretical calculations based on sort of the water. There's some water vapor in the air column, and it's evenly distributed, which is virtually never the case, really. And with evenly distributed water vapor, you'll see a moderate reduction in direct solar irradiance. But as is our common experience, on a cloudy day with an optically thick cloud layer, you get a severe reduction in the direct solar irradiance, but a great increase in the diffuse component. So, for example, if you try to look up at a bright cloudy sky, it can be fairly blinding across the whole field of view. And then, of course, if you have, say, a high altitude thin layer, then it's a moderate case. But what that means is that you probably want to assess the conditions in your location for the eclipse to decide whether or not you need to be using a filter. Generally, if you want to be safe, use a filter. That's the conclusion. But you might choose to shoot without one in certain conditions based on your own risk assessment. I'm not advising you to do this. It's something you can think through and make your own decision on. But these are the factors that will allow that to be a potential choice. So low sun altitude, clouds present, limited number of exposures, not a long video shoot. That may allow you to take a few stills without a solar filter, and that can help capture the true color of the sun at sunrise when the light's scattered and we have more red, orange, pinks, etc. So I hope that's given you a few thoughts on how to think about your filter choice for this upcoming eclipse on the 29th of March.